again. 0 and 1. Take the derivative, factor. If anybody didn't factor, shame upon you. 0 and 1. Number 14a. You guys see it. What's another way this could be written? Yeah, 1 minus 3 over x squared. Good. Oh, look. I think like the book. Anyway, so number 16, power rule. Wait, how did they just do a power rule instead of the product rule? What'd they do first? They foiled, and then they were like, psh, got it. So if you did the product rule, it might look a little bit different, yeah? The product rule would have been, you couldn't have factored out anything. I guess you could have factored out an x. That's about it. 24a, 2, b, negative 10, c, 10 ninths. Ah! Well, because it's the answer. 6 minus 4? Oh, u of 2. They're just showing the notation. They're just showing the of 2 part. For b? Did you do the bottom squared? Oh, okay, okay. Like your plugging in was right. Got it. All of it was wrong? Okay. All right. Well, that it is. All right, so then we have 10 ninths, right? And then negative 12? Negative 12 minus 4 is negative 16. Negative 16 plus 4 is negative 12. V of 2. You mean V prime of 2? Who's this for? Senior man. Thanks, Hannah. Senior man. That's hilarious. Sorry, what's something's not being plugged in right?
V of 2 is V of 2 equal 2 or does V of 2 equal 1?
You mean V prime of 2?
No. V of 2. Okay, so that's why on my last one.
Wait, why are you plugging in? Oh, for the earlier ones. Is that it? Yes. Oh, okay. But wait, did we figure out D? What went wrong? Aww. Yeah. All right, and you figured out what went wrong on letter D? I don't know either, but it's okay. He doesn't want to discriminate. Make sure everybody gets one. Maggie, we good? It's okay. Six minus, which one are you on, C or D?
I'm on D. I'm going to
Negative 12 minus 4 plus 4. Did they give you guys points? Why was it weird? What was this problem? What number was this, James? Oh, they gave you hints.
I think the problem was they took the derivative, so like, Arian and I just like took the derivative of the original thing, and we just had 3 minus 2. We didn't take u prime and v prime.
You didn't think chain rule.
First part, yeah.
That makes sense. Mr. What?
That's funny. Just like have a big like SAT prep book and just like hold it with you. Oh my gosh,
That's not funny. That's not funny.
He can be whatever person he wants to be. Okay, so at least for Mr. HES. For letter D, you know what I mean. You guys are making this. Anyway, why was it 3 U prime, 2 V prime, and 2 product rule?
I only put 3 and 2. 3 minus 2.
Yeah. That's what I think a lot of people did. That's what James is saying. I think Arian, that's what you did too. Why would you take the derivative of 3u and just call it 3? Because you weren't thinking of chain rule. Look at front. Look at the front. Wasn't it ddx, not ddu? If it was ddu, it would be 3. If it was ddv, it would be 2. If it was dduv, that's not going to happen. Anyway, but it was ddx, so you had a little u prime, v prime product rule with prime primes. Does that make sense? All right. Okay, moving on. Number 28. Your final derivative is 2x to the fourth minus 4 over x cubed. Your tangent line, which should never have an equation plugged into the slope, but always a constant, would be y minus 3 equals 2 times x plus 1, or that simplifies down to be 2x plus 5. Yeah, you could do y minus 3 equals 2 times negative 1 to the fourth minus 4 over negative 1 cubed times x plus 1. I was saying you could have just left that unsimplified. You can stick it to the man, as long as you make sure it matches up. But guys, what is this entire homework assignment highlighting? Could you check the evens? I mean, I guess you could have gone Slater. That would have been kind of dumb. But could you check the evens last night? Theoretically, no. And are some of you marking more wrong than you're used to? Oh. Okay, so never mind. Long story short, what's one of our weaknesses? The little things, right? Yeah. 34. When did the derivatives become trivial? Do you remember that term from last year? When did the derivatives become trivial? Yeah. Here and beyond, every other higher ordered derivative will be 0. Here's something super random, kind of along those points. Let me get rid of, sorry, someone's notes I can get rid of. Whose notes? Not theirs. Theirs? Yeah. Hey guys, higher order derivatives, I know. I apologize for how messed up my computer is, but here's what I was trying to do. I was trying to get to where I could come here. Something super random from pre-cal. It just came up today, and it totally tied with higher order derivatives in my mind. Ready? I was talking with the honors pre-cal kids about this notation. Okay, what is that? Who is that? F inverse of x, right? What do you think I was trying to make very, 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 very clear with them from the very first slide of this notes? It's not? Yeah, what is she talking about? It's not in the denominator. Why isn't f in the denominator? It's not? Yeah, what's the snazzy term for that? Reciprocal. Okay, why am I bringing that up right now? Because I made, for the first time, which I don't know why I haven't thought about it before. Genius sometimes comes late. Or not at all. Anyway, I made a note that I was like, if you want to raise a function to a power, the only proper notation to doing that is that. How does that apply to higher order derivatives? If that's the only way, if you wanted to do reciprocal, it would be this to the negative 1. If you want a square function, it would have to be this squared. You'd have to put the entire function with the power. This is the only proper notation for functions to powers. Why am I bringing this up? Same thing with derivatives. Derivatives can be easily confused with powers the same way inverses can. Why? As soon as you see something like f to the 4, what did some of you think? Most of you would think that's a fourth derivative. But as soon as you saw something like this, what do some of you think? Yeah, and it's not. The only way to raise a function to a power is using this notation. So as soon as you see something on the inside, now is that a derivative? No, that's f inverse. That's pre-cal. That's something totally different. But the idea is whenever you have powers inside, it means something other than a power. So for our purposes, any positive numbers will be nth derivatives, right? So I know they use the y prime, y double prime, y triple prime, but the AP never uses y primes. Rarely ever uses y primes. I should never use never with an AP. But anyway, function notation, these are the nth derivatives. So if you have something like f and with an n, what's it talking about? Derivative, not a power. Are we cool? Okay. It was random, but since I just thought of it today, I was like, oh, hey, that's the only way to do a power. Should have taught that like in Algebra 2. Maybe he does and everyone forgets. Anyway, number 36, you guys already check it? All the way down? Oh, got it right. Okay, number 38. Were you trying to find when the slope was 4 at plus or minus 1? The equation of one line, y plus 2 equals 4 times x plus 1. The equation of the other line, y minus 2 equals 4 times x plus 1. Smallest slope occurs when it's minimized, and it happens at 0. At the points where the slope is 4. So instead of doing horizontal tangent lines where you set the slope equal to 0, you set the derivative equal to 4. Does that make sense? So set the derivative equal to 4 because it says the slope has to be 4, right? Three x squared plus 1 equals 4. Oh, you said it equal to 0. Didn't you? Because you subtract 1, and 3 divided by 3 is 1, so plus or minus square root of 1. Oh. Ah, plus 3x. What was the original equation? X cubed plus x. Oh, you were looking at 37. You stole the equation from 37. I think. Actually, I'm not sure. Maybe from 39? I don't know. Something or others. Was that question kind of weird? Not only the slope being 4, but also the smallest slope of the curve. Was that weird for you guys?
Wait, I was just wondering, is that just the minimum of the derivative?
Yeah. So it asked to find the smallest slope of the curve. And the smallest slope of the curve, I mean, could you guys have done a whole like relative minimum thingamabob, absolute min thingamabob? Yeah. Or could you have thought about a parabola? So you could have done the vertex. Now, the tricky thing is that this isn't in like vertex form, so it would have been a little bit harder, but you could have thought about, nice pre-cal formula. If you have ax squared plus bx plus c, the vertex h, or the vertex x value, will always happen at negative b over 2a. Or you could have realized this is just a parabola that's been shifted up, and then it has a little bit of dilation going on, but still, where's its vertex when x is 0? And so then 0, 1 is the smallest slope, and it happens at 0. But yeah, you could have also taken the derivative. True. You were thinking of the numbers, like if you plug in negative numbers, it goes up, plug in positive numbers, it goes up, so 0 is the lowest. So you were thinking of like how the function behaves. That works. If it was a more complicated one, yeah, Aryan just, I think is what you were saying, just minimize the function. So take the second derivative, set equal to 0, critical numbers, go from there. Yeah. Yeah. All right, are we done? Is this the last one? Any questions on the non-existent odds? Or the evens that we just went over, that we didn't stop and pause on that you needed us to? Okay. Right now I want you to look at your paper. How many of you guys that did the homework, well, who either didn't do the homework or did do the homework and has some sort of colored mark on their paper right now from grading and having to mark wrong? Okay. Can we make little mistakes? Yes. Do we need to be careful? Yes. On the test on Thursday? Yes. Okay, section 3435. Here we go. What do we need to talk about? Why my computer is frozen. Okay. Kiddos, the very first problem. Related. What? Cylindrical balloon. Radius is 1/4 h. Find how fast the volume is increasing when r equals 2 inches. How fast? As soon as you see that, what should you be thinking? Velocity, you can think of that, or in a more general term. What's a more general term than velocity? Vector, magnitude? Pause. You're just making it too hard. What's another word for velocity? Speed would be without a sign. So velocity, what still maintains a sign? Just a rate of change. And why am I saying that? Velocity really only applies when you have actual motion. Does that make sense? To talk about the velocity of a balloon, it's kind of weird. You're like, how fast it's going? Which, I mean, if it's rising. But if you're talking about like a rate of change, how fast the volume is increasing, I'm just trying to remind us that rate of change is the best way of thinking about it. Velocity is one specific application. Okay, so how fast the volume is increasing when R equals 2 inches. Maggie, why'd you ask me volume of a cylinder? Yep, because you need to be thinking about V equals pi R squared H. Sometimes you got to go find your own formulas. They can't give you everything all the time. Life lesson to that one. Sometimes it hurts. Coming back. How many variables do you have? Yeah, too many for what's given. Way too many for what's given. So what are we going to do? Do you guys see a clue? I see a clue. What can we do with the clue? Plug it in, plug it in. And we end up with, in terms of mental mathers, are you there? What do we got? 1/4. Why is this one not going to be nice if we go plugging in H's? Yeah, they're asking for, I mean, they're not asking, but they gave us a clue about the R. So it might be a little bit nicer to go ahead and rewrite this as H equals what?
8.
Don't go plugging in the 2 until after you derive. Because if you plug it in earlier, you're saying, hey, this is the only possible answer. It never changes. It's only constant. That's bad. So now if we plug in the 4R, now we can go ahead and say, what, 4 pi R cubed? You guys agree? Remember the 2, we're supposed to be finding dv dt. The 2 is the such that. And what do we do with the such that's? Leave them until the very, 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 very end. This is moving, this is changing. We can't make it constant too early. So how fast? What do we do now? Yeah. Now here's the question. In context of the problem, am I taking the derivative with respect to R or with respect to T?
No, it's R. That's why you're not doing the RDT. It would be like f of x. But it's like
Have they given us any information about time? Have they asked us any information about time, like in meters cubed per seconds? They haven't talked about time in any way, shape, or form. Have they talked about how fast the radius is changing? How fast the radius is changing? Yeah, but is there anything about drdt? No. Is there anything about dh dt? Because if we took the derivative of, we have nothing about anything else changing except for volume. So in context of the problem, could there be something that looks like a related rates problem, but it really, really isn't? They're just asking us for what's the rate of volume. So we're not trying to find dt, but what's the problem? A lot of your brains are so programmed, which is good, but I need you guys to step out of the programming and realize it should have just been dr. Time was never brought in. This is just an old-fashioned find the derivative, and you're like, okay, fine, so v prime is equal to 12 pi r squared, and you're like, yeah, and then you plug in 2, and you're like, yeah. So such that r equals 2. And we end up with 48 pi. What would my units be? Oh, it's inches, that was meters. Inches cubed per, yeah, inches cubed per inch. Could you simplify that? I suppose, but what would get lost if you did simplify that? I was just thinking the meaning. Because the rate is how fast volume is changing with respect to radius. So it's like, okay, the volume, the cubic measurement of volume is going to increase 48 pi per inch of radius that's added. So in some ways, like our meaning totally disappears if we just go simplifying the inches cubed over inches. Sorry, inches cubed over inches. Anyway, all that to say, rates. If you're just trying to find the rate, you're trying to find a derivative. Now, there are times where there is related rates, and we do have like a third variable like time that we have to consider, or I should say a fourth variable like time. But I just wanted you guys to know that in these sections, you have to keep an eye out. They're not all related rates problems, and to be honest, I don't think really any of them are. Just keep an eye open. They're rates, but they're not necessarily like the complicated related rates. Does that make sense? Okay, so even in the book, the first example had something to do with enlarging circles and finding, using the area formula of a circle, a equals pi r squared, and asking you about the rate of change of a. Now the nice thing is it says with respect to r. So remember, keep an eye on the with respect. They might not be talking about d dt at all. But in the motion ones where you have time, okay, obviously t is going to be a variable. You're going to be taking derivatives d dt. What's going on if the position is positive? No, let's fill it in. Moving to the right. Isn't that down here? So moving right. I'm trying to challenge your thinking. So then what's negative velocity? What happens if position is positive? Function's positive, but in context of a problem. What were you saying, Maggie? Yeah, you guys are trying. You have to explain it to me.
Above the zero. Above
The graph of motion would be above the t-axis, I guess. Yeah. What's it mean? Can I say it's been displaced to the right? What am I talking about if I'm saying displaced to the right and displaced to the left? What am I needing if I'm talking about displacement to the right or to the left? It's a change, but if I know if, how do I lead you to this? Yes, but the starting position could also be positive or negative, which is also to the right, to the left. So is the starting position necessarily my reference point? No. So it's displaced to the right or to the left of some sort of point of reference. There's always some sort of point of reference. Where is zero? Is it the ground? Is it the plane? Is it the starting line? Is it the finish line? Is it 100 yards into the race? I don't know. There's always a point zero. There's always a reference point, but it can be many different places. So positive position, negative position, all it tells you is how far away it is from whatever position zero is, which might be the starting point or it might not. Instantaneous velocity, we know what's going on, right, guys? You find the derivative of position. Or, the integral of acceleration, that's future. Speed, we have that up here. Magnitude, the how muchness of velocity. I put the quick reminders from, I think these were forever cards last year, right? The increasing, decreasing. We need, wherever we are, to the right or to the left, doesn't really matter, but in order for something to be speeding up, we need the velocity, the way it's headed, and acceleration, the force, I don't want to use the word force, the push in the direction to agree. We need the velocity and acceleration have the same sign. Velocity, acceleration, if they ever have the opposite sign, they're working against each other. Speed is decreasing. Did a lot of visualization of that last year. Acceleration, we know, is the rate of change, the first derivative of velocity, which is the rate of change of position. Second derivative of position. And does it make sense why if acceleration is positive, all I know is that velocity is increasing? Increasing, decreasing test. The first derivative's sign denotes the increasing or decreasing of the original quantity. What's jerk? Third derivative. So that would be x triple prime. The rate of the rate of the rate of change of position. Or the acceleration of velocity. I shouldn't say that, but the rate of change of the rate of change of velocity, or the rate of change of acceleration. And you're not going to really see that necessarily a lot, but I thought it was nice to bring in just in case of a physics class someday. And how do you remember that jerk is the rate of change of acceleration? What happens if someone's having serious issues like a stick shift in their accelerator pedal? Yeah, you're going to be jerking all over the place. Hannah.
Will we be getting our tests back today?
Oh, I do have them. They're actually right up there. We have time. But let's finish the section first. Do we still remember? All right. Trig derivatives. Is there a forever card? Yes. Should we know the derivative? Didn't you guys already write down the derivatives of sines and cosines? You did, right? Yeah. Okay. So what are we missing? Sine, cosine, tangent. What's the derivative of tangent? Okay, but what if we forget? Can't you do the derivative of? Don't do 1 over cotangent. That's an awful idea. But sine over cosine would be great. Then you can do quotient rule. And your quotient rule, bottom d top, would end up being a negative cosine squared minus top d bottom, which would be a negative sine squared, all over bottom. Oh, bottom d top. What am I doing? Bottom d top is a positive. I was doing integration for a bit. That's a struggle. You guys do it too. Bottom d top, derivative of sine is positive cosine, minus top d bottom, which would be minus a negative, all over bottom squared. If you were to ever forget, forever quiz, you should never, ever, ever miss any trig rule ever. Couldn't you always just find it to be 1 over cosine squared, and you should be able to attach that to secant squared? It does, but if worse comes to worse and you totally blank out, there is a way. But we're not going to do that for the rest. What's the derivative of cotangent? Uh-huh. And if you were to do it the long way, wouldn't that be cosine over sine? Cool. And the negatives would just happen? Mm-hmm. What's the derivative of secant? Secant x, tangent x. Some of you still don't have your signs down. Wouldn't that just be the derivative of 1 over cosine, or cosine to the negative 1? Bring down the negative. Derivative of cosine is a negative sine, and negative times a negative is a positive. Well, and there's more quotient rule stuff, but. And then derivative of cosecant. Negative cosecant x cotangent x. Kids that skipped CalcB are forever cards. You're getting farther and farther in because now we're up to derivatives of trig functions. Gonna have to use them. And we're done. Hey, how many of you guys have written down homework number 9 yet? You guys write it down as I pass out your tests. Go team. Oh, you can pass it that way, Kathy. Sorry. No, I figured you were like, oh, you have it for the whole semester. Sorry. I don't want to make you responsible for holding on to all that. I know, it's weird. Our rows just kind of go sideways. Okay. Remember how you guys did reflections on this test? We don't need to record anymore, right? You guys know to do this homework.